hopefully you enjoyed the presentations given by my colleagues as well the days before. So I know that you've heard a lot of stuff about high performance computing and GPU during these last days, but today we're gonna speak about a different topic. So both Christos and I will be talking about data science and how we can use Python essentially for data science projects. So hopefully by now you've all seen some examples where actually we need to solve some problems with large data sets in your daily work or in your organizations. I'm sure that you have similar problems. So we're going to start a bit simple today and then gradually move on to more specialized topics. So for those of you that want to follow the notebooks presented, you can go to the GitHub repository here. So in day 3, and you can access the 2 notebooks in this section here, but I'll also share the corresponding links in the chat. So this is for those of you who again want to share the notebook, want to access the notebook and be able to run it at the same time as me. For the rest of you who just want to watch the presentation, that's fine. And for some reason, okay. So this is the link for the first notebook. And I just want to kindly ask you, for those who want to be running it at the same time as me, just go to File, save a copy to your drive, and please run the copy, not the original one, because that's going to mess up my runtime, because you're going to be editing the same notebook as me. So for those of you who want to run the notebook and have a Google account, so a Gmail, just save a copy to your drive and please run the copy. So as I said, today we'll be talking about Python in data science, right? You've been hearing this term a lot lately, so data science. It's a really hot term. Most companies now employ data scientists, and it's described as one of the hottest jobs in the century by some. But it's a term that's loosely used, and most people don't actually know what we mean by data science. So in general, in data science, we combine scientific methodology, our programming skills, and some mathematical and statistical knowledge in order to derive some insights from complex data sets that we have in hand. And as I said, even though people mean different things by data science, we can summarize the main responsibilities or the pyramid of the hierarchy of needs, essentially, of data science in this pyramid. So most of the people in the community agree that the hierarchy of needs in data science can be visualized this way. So essentially, we can start by collecting the data and store that somewhere, so safely. And most companies use data lakes for this, or big databases. And then we need someone actually to manage the data, so how it's going to be transferred safely from one place to another. And then we can move on to higher levels of the processing, such as cleaning the data, finding outliers, anomalies, and then preparing it for the task we want to be solving. And then, of course, we perform our analytics. So we explore the data sets by some analysis using some specific tools. We want to identify some features that are useful for tasks that we may be working with. And then we can formulate a hypothesis. So this is called A/B testing in data science. Start implementing some simple models, see what works, what doesn't work, and then we can move on to more sophisticated stuff such as deep learning, convolutional neural nets, and all of that advanced stuff we've been hearing about during the past years. So mostly data scientists are involved in the top 4, I'd say, levels of this pyramid. And today we're gonna mostly be seeing how to clean the data, prepare the data, explore, and do some analytics, and also how to implement some simple predictive models on some actual data sets. Christos later on is going to show you some more advanced things on artificial intelligence, but we first need to build some basic skills. And of course, this starts from analyzing the data. I know that many of you use different tools for doing this, but Python is a really powerful tool for data science in general, because the main libraries for machine learning and artificial intelligence are implemented in Python. So we have TensorFlow, we have PyTorch, which are really powerful for doing this stuff. And as most of the work is actually being done in Python, people build tools for preprocessing the data in Python as well. So an extremely powerful tool that I'm going to be showing you guys today in the first slot is Pandas, which essentially is a data analytics library, which has tons of functions for manipulating data, plotting, conditioning, and we'll see these together in this notebook. This is quite thorough introduction, I'd say. We're going to go through the basic functionalities of Pandas, and we're going to see what we can do with it. And later on in the next notebook, we're going to actually take what we've learned and implement it in order to solve a predictive modeling task. So we can start, for those of you who never saw a Google Colab Notebook, we can present code in this interactive way. So we can run cells by pressing this button, or just shift and enter within the cell. So here we just import our relevant packages. And we have Pandas here, Numpy, which is for mathematical operations, Matplotlib, which is for plotting, same as Seaborn here is for plotting as well. And now we want to find a way to essentially read our data into this notebook. So because this runs on the cloud, an easy way to actually get data into Google Colab and start experimenting is by mounting the notebook to our personal drive or the Google Drive where the data is stored. But because you guys don't have access to my drive, we're going to read this data that we're going to be using today directly from GitHub. And it's available here in this folder. But you don't need to do anything. I'm just showing you where you can find the data. So we'll be using these 2 data sets here. So for the purpose of this notebook, I chose a pretty simple data set. So it's a really introductory data set that everyone in the data science community saw at some point, because it's really like well structured, and you can actually play around with it a lot. So it's called the Titanic Data Set. It's freely available on Kaggle. And it actually describes the passengers of the Titanic and some of some features that can be used to describe them, and whether they survived the crash or not. So we don't know if this data is real or if it isn't. Some people claim it is, but we don't care about that right now. Just we're going to use it for manipulation and analysis. So The columns in this data set are the survival column, so whether someone survived or not, the ticket class of the passenger, their sex, their age, their number of siblings, their number of parents or children that are on the ship, their ticket number, the fare that they paid, their cabin number, and the port from where they left. Okay. So as I said, this is saved on GitHub. You can access it later on, and it's also available on Kaggle. It's there to download. So here I just specify the URL of the raw data on GitHub. This is one way to load data into Google Colab. So you just specify the URL. And then once you have this, you can just read the files using this, depending on the file format. You can use the corresponding command. So it's really important to state that Pandas can read loads of different file formats. So either Excel, JSON, SQL, HTML, whatever your data is in, Pandas can read it as long as it's tabular. So Pandas is for tabular data sets, which most of the organizations are dealing with. And it's extremely useful for tabular data manipulation. Most people use CSV files, so they're really lightweight. They contain plain text, and each line is an individual row, essentially, in the data set. So here I'm going to read exactly the same data, both from a CSV and an Excel file. So both of these files are exactly the same, but the one is CSV and the other is Excel. And I'm loading both of these data sets now using the read CSV for the CSV file and the read Excel for the Excel file. Although the two data sets are equal in terms of what is included in the columns, Pandas will say that they are not equal. And we're going to see later on why this holds. Many of you can already guess that there are some different data types, even though the actual numbers and the actual entries are the same. So we can access the shapes of the data sets here. They're just two-dimensional arrays, so they have a number of rows and a number of columns, and we can check if they are equal. And also we can get their columns as a list. So by dataframe.columns, you can get all the columns of your data frame. And then if you do to list, that is transformed to a list, essentially. So as we can see here, the lists of both columns are exactly the same. So that's fine. And we know that somewhere here, we've got a mismatch in data types. So in this for loop here, I individually check if each column is equal to the corresponding column in the other data set. And we can see that the ticket column is actually different because of its data type. So I claim that the data type is different. We can just, so one of them was string and the other one was actually integer because the ticket number is just an integer number. We turn both into strings and we can see that now they're equal. This was just to show you guys that even though you can load data sets that are identical from different sources, you might have some data type issues that you need to be careful of because you never know how this is going to affect your problem down the line. Now that we actually have the data sets loaded, we don't care about the two different data sets. We're just going to use one. I'm going to use the CSV one, and we can get some information about this data set using the Dfinfo function. So here we can see that we have so many entries, 12 columns, and we can also see the data types of each column. So we have integers, some categorical columns, and some floats, which makes sense. So if we want to actually start visualizing the data, so seeing what's actually in the tables, we can use, instead of printing the whole thing, we can use this head function, which gives you the first n entries of the data set. So you can specify how many you want. So let's say if I say head 10, it gives me the first 10 entries of the data. So let's say here we have a really nicely visualized the Pandas data frame, where we have our rows, our columns, and we can actually see what's going on within our data. And this is really fast and efficient. Same goes for tail. So as we have head, we can also print the tail of the data. So the last n rows again. So here I just specified the number of rows to be 7, but we can do this for as many rows as we want. The default is 5. And this command is just df.tail. Now, if we want to start, selecting more specific subsets of our data, so let's say specific rows, specific columns, that's something we could absolutely do in Pandas. And it's really straightforward to do this. So as I've shown before, you can get the columns by df.columns. So here I just get the columns as I've shown above. And we can also access specific columns by specifying the column name in brackets. Okay. So if, let's say, I want to access the sex column, I can just put the name of the column in brackets and just print out what I want to see. And also this is equivalent to just doing df dot the name of a column instead of putting it in brackets and in quotation marks. You can access columns this way as well. So df dot the name of the column. This is completely equivalent to the command I'm using here. Now, if you want to access rows by their, by the specific number of rows, we use the iloc operator here, and we put the number in the bracket. So if I want to access this is the second row actually, because Python indexing starts from 0. So I just put the number in the brackets of iloc, and I get the specific row. So here we have all the columns for row 1, which is essentially the second row. And we can also start specifying ranges of rows with like this format here. So where we want to start and where we want to end. And this is the first. So the brackets here take 2 arguments. The first one corresponds to rows, and the second one corresponds to columns. So if we want to access, let's say, a specific row and a specific column, we first input the row, then we add a comma, and then the column. So that's, again, really simple. This is the 4th row and the 3rd column, and this is the entry that we have there. So now I've showed you how to access some really basic things in a data frame. Besides just using the number of a specific row number to access an element, we can use the index of that row. This is not always the same, because sometimes when you filter your data, the first row, for example, could correspond to another index. So this lock operator here refers to the index, not the row number. So here, actually, this is really convenient, because the first row has actually position 0 and index 0, but this is not always the case, and we're going to see an example later on. Now, sometimes we want to, let's say, change our column names, because we want to make the data frame more, readable. We want to show it to someone who hasn't seen it before. So we need to make, column names more interpretable. So a nice way to do this is to just define a mapping dictionary between the old name and the new name. So here I want to rename, let's say, P class to passenger class. I want to rename this thing, whatever it means, to number of siblings. And I want to also rename this to this. So I just rename using a dictionary mapping, which I define up here. And I just do df.rename. And then I specify the mapping that I want to be using. So as you see here, and Nikos talked about, if I want to actually update the data frame, it's not enough to just run this command, because this will just show me this is temporary. So this doesn't save the changes anywhere. So if I want to actually save the changes, so actually rename the data frame, I either have to update the original variable, so update the variable with a change, or use this in place argument here, which does this in one line without needing to update the variable per se. I mean, to type out the equality and then update the variable. So I just summarize this here. As you can see, I can either do this, so in place without redefining the variable, or I can redefine the variable and then give it the value I want to be updating. And of course, in this really first simple section, some of you may ask me, how do I actually, sort my data? And this is really simple in Pandas. So you just specify the column you want to be sorting on, and then whether you want ascending or descending sorting, and you just run that. And as you can see here, we've sorted the entire data frame based on the fair column. So this is quite straightforward, plain English, it's Python. If someone has any questions, please ask. If not, we can move on to some more interesting stuff. Okay, so another really useful thing we want to be doing when analyzing data is filtering the data. So sometimes we have some conditions that we want to apply on our data set in order to get out a subset of the data. So we might want, let's say, only passengers that were older than 18, or passengers that survived the crash and they were in some specific cabin. So this is just for this example, but of course, a really important part of data analysis is filtering the data. So in Pandas, this is really straightforward. So although you can add additional constraints and you can make the formulation more complex, it's really straightforward to filter data, and we have some really nice tools to do this. So as I showed before, we can actually access rows and columns using the corresponding arguments in the location, or in the corresponding locations of the data frame. So let's say now if we want to access every row and every column besides a specific one, we can do something like this. So we access all the rows and all the columns besides one. So this not equal operator is used to specify the column we don't want. So this just gives every row of the data frame and every column besides one. And essentially we can extend this logic to more complex constraints. So first of all, we can define a constraint on the rows of the data set. And then we can also define a constraint on the columns of the data set. So let's say now, again, this is pretty simple. We want to get a specific chunk of the data by defining a slice of rows and a slice of columns. So let's say we want the first 5 rows and the last 10 columns. This is exactly the same as above. So again, we define here the constraint on our rows and the constraint on our columns. And by running this, we essentially get the required output. Okay, so just 3 columns and just 6 rows. Again, this is really simple. It's just an extended version of what we were showing above with simple indexing. Now, if we want to actually start adding conditions and stuff like that, we can use Boolean indexing, which essentially it takes a condition and checks whether it holds in the data frame, and only returns the entries where the condition holds. So for example, if I wanted to access passengers that are younger than 18 years old, I'd add a constraint to the age column, right? So I'd want passengers to have an age less than 18. So I do exactly this inside my brackets. I specify what I want to be filtering, and then I essentially return the rows where that is true. So again, I'm just using this head function here to return the first 5 elements, because otherwise you'd be getting like really big data frames. But as you can see here, this does exactly what we wanted to, because we're getting only the people that have an age less than 18. Here you can start seeing the indices becoming a bit messed up, because now you're not getting the entire data frame back. You're just getting some specific elements of the data frame. So the indices are not continuous anymore, and this might cause some issues, but we're going to see how to actually solve that later on. So if we actually run this on its own, so if we actually run data frame.age is less than 18, we get a Pandas series, which is essentially a one-dimensional array with the corresponding indices, where we have a Boolean value for this condition. So we just get a true value if this holds and a false value if it doesn't. Then by feeding this to inside the brackets, we actually can get the conditions we want and return the updated data frame. Okay, so we can start doing other stuff as well in terms of conditioning. So something we can do here is, for example, play a bit with the columns that have string values. So for example, the name column here, let's say we just want to get back the names which have the string miss in them. So this is again pretty straightforward in Pandas. We just define the column which we want to be conditioning on, and here we're dealing with strings, and we want to have miss inside the string. So again, this will return true wherever this condition holds. So whenever we have miss inside the passenger name. And by running this, we can get the corresponding section of the data frame. So someone could actually claim that, whenever we have, let's say, miss in the name, the passenger is a female or whatever. And we can actually check this. So if, let's say, you want to see the difference between two data frames in Pandas, you first need to concatenate them, which we'll discuss a bit later on. And then you have to drop the duplicate values. And if you think about this, it actually makes sense. So you take two data frames, stick them together, and then the duplicate values are the ones that happened in both data frames. So you don't want those. The difference between them is just whatever remains once you drop those duplicates. So here I just...
Sorry, can I stop you for a while and ask a question here?
Yeah, sure.
Is this case sensitive?
So you mean this condition here?
Yeah, so if I put miss with the small m?
Yes, it's case sensitive. So if you want to be doing, let's say, more complex stuff, so in general in Python, if you want to ignore case, you can make everything lowercase and then check the condition in lowercase. Or if you do this in this way, this is case sensitive. So if I do miss with a lowercase, you actually won't get anything back. So yes, it's case sensitive.
Thank you.
No problem. So yes, as I said, you need to, in order to find the differences, you need to concatenate the two data frames and then drop the duplicates. But concatenation is something that I'm going to show you a bit later on. This was just to show that this claim isn't true. Now, I've showed you how you can place individual constraints on columns. So let's say this is one condition, this is another condition, but sometimes we want to be adding more than one condition. So in real world problems, you'd have really complex conditions with multiple cases, and you'd want to filter your data based on that. So you may end up with a huge expression of Boolean logic where something needs to hold and something else doesn't need to hold. And you have OR operators and AND operators and stuff like that. And this happens all the time, especially when you want some specific subset of your data. Thankfully, Python and Pandas, again, allow for this kind of stuff. And the way to do this is just place, again, your conditions, so your multiple conditions inside the brackets. And then you can have individual conditions in parentheses, and between them, you can use the corresponding operator. So for example, here in this generic case, if I want both conditions to hold, so to essentially to have an AND operation, I put condition 1 in brackets, condition 2 in brackets, and then my operator here. So you can either use this for AND, tilde for negation, and you can use this vertical, I'm not sure what's it called, for the OR operation. So let's say this is an actual example for the specific case of our dataset. We want the passengers that are older than 18, so the ones that we got up here, or younger than 18, whatever, it doesn't actually make a difference. And the passengers whose name contains miss. So both of these conditions, we want them to hold, both of them. So this means that we're going to be using an AND operation. So we have condition 1 here in brackets, condition 2 in parentheses, sorry, not brackets, condition 2 in parentheses, and between them we have the AND operator. And we place this whole expression inside our brackets, which is relatively simple if you think about it. And indeed, we get the passengers that have age, as you can see in this column here, older than 18, and they also have Miss inside their name. So this works really well, and it does what we asked it to do. Same goes for the OR operator. So if we want one or the other or both to hold, we can use this expression here. So let's say we want passengers to have a ticket class, so or passenger class 1 or a passenger class 2 or both. You can't have both actually, but yeah. You can do this. You can follow exactly the same logic as above. So you can see here the passenger classes are indeed between those two values. So either 1 or 2. So okay, this is equivalent of saying I want the passenger class to be an element of this list, and you can absolutely do that. You can just say I want the entries where the passenger class is in this list. So this is equivalent to the above, and it works for this case. Of course, in other cases where you use this kind of Boolean logic, this wouldn't work. But for this case, we get exactly the same thing as above here. And now, finally, if we want to negate an expression, so if we want to use the not operator, essentially, we can just add this tilde before our expression. So this essentially is the negation of this condition here. So it's where the passenger class is not in this list. Okay, so you can apply this even here. So you can just add the tilde operator and negate an individual expression that is within the parentheses. So if, for example, now we filtered our data, so I don't know, I want the subset of the data set, which corresponds to only passengers that have class 1 and class 2. I can absolutely save that in a new data frame and store it separately. And I can do this by just creating a new variable and adding the corresponding subset of the data to that variable. And now I have a new data frame, which is, let's see, it's quite smaller, so it only has 400 entries. And if we just print it, we get this filtered data frame where the passenger class is either 1 or 2. Okay, the reason
Can I ask a question?
Yeah, sure.
If we change the filter data frame,
yes,
will that change the original one?
No, this is a separate object.
Because I know there's an issue like that with matrices in Python.
No.
Okay, thanks.
But you can also, just to make sure you can save a copy, you can save a copy of the data frame, but this is not necessary. It's a separate thing. So yeah, the point I wanted to make here is that now that I filtered the data frame, we've changed the indices, right? So now the indices are not continuous. So we go from 1 to 3 to 6, and this is not a direct problem, but it may, cause some potential issues down the line. So Sometimes it's good practice just to reset, depending on the case. Always we can reset the index to have, you know, this continuous nice form from 0 to 399, because Python indexing starts from 0. And if we do this, we can actually do it using the reset index. So if we do this, we can see that we now have the old index as a separate column. So the old messed up index we had here, and we have a new clean continuous index for our filtered data frame. So again, this does not save anything. The command I just ran here. So this just temporarily shows us the command I just typed. So in order to actually save this, we can either update the data frame as I showed before, or again, use the in place operator as I've shown above. Now, another thing we want to do maybe is drop this new column, the old column here. So the old messed up indices, we don't need them for some reason now. And we can easily drop those in one line of code without doing anything extra. So this line here does exactly what I did above. So it resets the index, it drops the old column here, which we don't want. And also it saves the updated data frame without having to actually rename the variable. And now we can see our nice, clean, new updated data frame here, where the indices are continuous and we don't have this old index column like we had above. Now, I've showed you how to filter data and how to get subsets of our data frames, which is quite useful, but sometimes we want to use the conditions on columns and on rows in order to update other columns, not only to get subsets of our data. So let's say we want to make a conditional change on another column. So let's say change column, let's say change the fair column based on, I don't know, the age of the subject. This is again something we can do easily. And the general expression for doing this is this line here. So what I'm showing here is the expression for changing a column based on another one. So let's say I want to add a condition and update another column. I can do this by opening the brackets, my usual brackets, typing down the condition on the column I want to be conditioning on. Then in the second argument, I actually give the column which I want to be changing, and then the new value which I'm going to be using to update the new column. So let's see this in an example, because you know this might look a bit scary for some people. Let's say I want to create a new column which I don't have here yet, which is which will describe whether the passenger is a child or an adult. So in order to do this, of course, I need to condition on the age column and see whether the age is less than 18 or greater than 18. And according to that, I need to update my new column with child or adult. And this can be done using this expression here. So for simplicity, I just create an additional column here, which I call child or adult. Okay, let's just see if this is the new column. So I could have placed whatever I wanted in the entries because I'm going to change them anyway, but I just named every entry adult, and then I'm going to update it with the corresponding correct value. Okay. So in this line, I'll do exactly what I told you above. I'm going to condition on the age column and update the child adult column. So first argument here is the condition on the column I want to be conditioning on. So I want the age column to be less than 18. And I want to update this column with the value child whenever this holds, okay? So if I run this and print the results, I can see that actually here we have an adult who is 27 years old, and here we have a child that is 2 years old. So this actually worked. Okay, of course, sometimes we need to add more complex conditions rather just a simple inequality. We want to add, maybe a complex function or something that takes many conditions and is, really complex in nature. So whenever we want to do this, it's better to define a custom function to apply the condition. Okay, I'm going to show exactly the same example for you to understand, but of course we can do this with other functions as well. So here I define a simple Python function, which is called check age, and it just takes in the age as an argument. And whenever that argument is less than 18, it returns child. And whenever it's greater than 18, it returns adult. Okay, so this is a really simple function, nothing special, one input, one string output. So if I want to apply this function to the age column, because it takes the age as the input, I just do df.age or df brackets age, whatever, dot apply my function. And this is equivalent. See, I get exactly the same result. And I can use this lambda function for simplicity, which is essentially a one-liner that doesn't take any arguments. Those of you that used function before have definitely used this. So another nice way to add to make conditional changes to columns is by defining custom functions. If, let's say, we want to be doing something more complex besides just checking a Boolean condition. Okay. So
how did you create the new column? I think I missed that part.
So this is really simple. So creating a new column, I just create a new column, and I did a mistake here. I just assign a whatever value to it, and then I create a new column like this.
Does it work the same way for a row, or is it you need iloc things?
No, you need an iloc for a row.
Mm-hmm.
And actually, there's although pandas is actually good for just reading stuff and conditioning on stuff. If you want to start adding tons of new rows, I'm not sure if you want to be actually doing it within pandas or to your raw data, if you see what I mean. Of course, if you want to be adding rows with some condition based on other rows, that's something that's possible, but I can't think of any cases right now where I needed to do that. Of course, columns are necessary because I'm taking this example towards machine learning. So in the next notebook, you'll see that whenever we want to add a new feature, a handcrafted feature, you need some condition on some other column.
Thanks.
Yeah, so okay, let's say we want to save a data frame now. You can actually, this is really simple. So same way we loaded the data frames, you can save them. You just need to define the file format you want to be saving to. So same as above, when I was reading a CSV, I was doing read CSV. Now, when I want to be saving the CSV, I'll just do to CSV. and same for Excel, and same for whatever. I'm not going to run this line here because, again, this assumes that the notebook is mounted to a Google Colab, sorry, to a Google Drive, and you guys don't have access to my drive. But if, let's say you want to you just specify the file path here, and you just save the notebook, the data frame using this simple one-liner here. So data frame to CSV, and then the file path, and it gets saved. So, okay, one last section, and then we can either move on to the next one or take a break depending on what you guys want. Sometimes we want to be grouping our data, and if we want to perform a specific analysis on a specific group of our data set, we can do a group and see maybe some summary statistics within that group and do some manipulations within that group. And in Pandas, this is called aggregation. So let's say, okay, I'm going to start simple again. When you want to, okay, group by some unique, let's say, value of a categorical column, you of course first need to know those unique values. So here I have the sex column, right, which has two unique values, in this case, a male and female. So I can access these unique values just by doing df.the column I want, which if I want unique values, it makes sense for the column to be categorical. And I can just print the unique values like this. So df, the column, and then .unique returns the unique values in that column. And I can also see the value counts of each of those unique values by doing value counts, again, plain English. So for example, if I do df.sex.value counts, I just want the value counts of this column. And I can see that we have so many males and so many females. Simple as that. I can also start printing some summary stuff on the columns. For example, if I want, let's say, the mean of a column or the median of the column or the maximum, the minimum, the standard deviation, all of these things are things that I can easily do in one line. Again, by specifying the column and then specifying what I want to get out of that column, right? So let's say here I just print the mean of the fair and the median of the age column. So this is, again, really fast, really simple. The reason I access the column here in a different way is just to remind you that it's equivalent to actually put this in brackets and or using the other notation. So whatever you want is equivalent in Pandas. So instead of, just individually sitting and typing whatever, statistic you want to be getting out of your data frame, row by row, you can just do this df.describe function, and then just specify the columns you want to be describing. So if I do df.describe, I get all these nice statistics here for these two columns. But I can also do it for the whole data frame, no problem. So I just get a description of the entire data frame with a count, a mean, a standard deviation, and different quantiles here. So this is really useful, as you're going to see later in the next notebook, because it helps you just quickly identify stuff that might stand out or gain a better understanding of what's going on inside your data.
Sorry, I suppose we can also perform some filtering or sorting in columns containing strings and not numbers.
Yes.
Depending on some certain conditions.
Yes.
It's also.
Yeah, that's as I showed before with the the contains. You can do stuff like that. But depending on the case, you might want to use regular expressions, which can get a bit messy. But there are some other libraries as well for string manipulation, which can help you out a lot, especially for natural language tasks. Because again, if depending on the task, if you want to be setting up your notebook, let's say for data science tasks, and you're dealing with a data frame of strings, and you want to be doing some manipulations on that specifically for natural language processing, for example, you have some really nice libraries such as Spacey or LTK, which provide one-liners for stuff that you would need to be, typing a huge custom function.
I suppose can I identify which columns have strings and not numbers?
Yes. So up here, so here, if you do df.info, you can get the data type of each column. And so in the object columns are strings here. And later on, I'm going to show in the next notebook actually how you can store those as separate objects, because we'll do some manipulation using the categorical variables and the numerical variables.
Okay,
thanks. So where were we? So equivalently, again, if this is kind of just writing this describe function manually, so you can use this aggregation function here to summarize specified columns. So you do again a dictionary where the key is the column, and the value is essentially the list of statistics you want to be printing. But I'd advise against using these more complex things, because you have these really nice functions in Pandas that do these things for you. Okay. Now, a really powerful tool for data analysis, which I've used tons of times, is the group by tool. So let's say I want to see some statistics within some groups, right? So I want to group by the sex, then the people that survived, and then on those groups, so let's say the females that survived or the males that didn't survive, get some summary statistics. So I can do this by grouping by the categorical columns I want to be grouping by, and then getting the statistic on another column, let's say. So for example, here I just said that I want to group by sex, and then I want to see also the people who survived and the people who didn't, and get their mean age. So using this expression here, I can group by sex, their survival status, and then I can also get their mean age. Okay. So for example, the mean age of females that didn't survive was 25, and the mean age of males who survived was 27. This doesn't actually make any difference, but I'm just showing you a really nice thing you can do if you want to be performing some kind of data analysis on a data set. Then of course, you're not limited to only one statistic. You can use this aggregation and get really nice summarizations of the count, let's say. So we have only 64 females that didn't survive, whereas we have 197 females that survived. We can get their mean, their standard deviation, their minimum age, and their maximum age. Okay. Of course, depending on the case, this can get a lot uglier, and we're gonna see some actual like how this helps us in the next notebook. Again, there's an infinite number of things you can do in Pandas. I'm just trying to show you some basics, and there are some really nice, step-by-step tutorials online, which can take you to the next level, of course. So just before I complete this presentation, I just wanted to show you how you can combine data sets. Of course, I gave you a flavor before when we wanted to see the difference between two data frames. For those of you that maybe worked with SQL or other databases, you know that this can get messy, but here I'm just going to stick to the core functions and some really basic stuff. And of course, again, depending on the task, it's good to, you know, see whether, let's say, if you're going to be using Pandas, if Pandas provides any other tools for doing what you want to be doing. So essentially, the two main methods to combine data frames is merge and concatenate. When you merge the two data frames based on a common column, right? So let's say here, I'm just gonna split my data frame into two other data sets. So this is one of them. So this is a data frame with two columns, which is the passenger ID and the fare. And then I also created another data frame, which is a survived data frame, which has, again, the passenger ID column and the survived column. So these two data frames have one common column, passenger ID, and one separate column, namely fare for the first one and survived for the second one. So essentially, you know that you're going to be merging on the ID column because this is a common one, but I'm just going to rename it here because, well, let's suppose we have a different column which has the same values. And then the way to merge, okay, is you add your two data frames, so left and right, okay, and you define how you want to merge. So you want to merge on the left data frame, which in this case it's df fare, and you define the column on which be merging on each data frame. So we know that the common column is the passenger ID, and it's called passenger ID in the left data frame, and it's called ID in the right data frame because we renamed it. So if we do this, we see that we successfully merged the two data frames. Of course, you can extend this to more than one data frames. To be fair, I saw people doing it, sequentially, so merging and then merging and then merging. I'm not sure. I'm not exactly sure now if you can do this in one line, for multiple data frames. And this is actually something that just came up, and it's good to find out. But in Concat, you can absolutely just stick together as many data frames as you want, because now you don't need the common column. You just need to stick them together. So let's say here, if I create two data frames, one of them is called df.head, okay, which is the head of the data frame. So the first five rows, and then the tail data frame is the last 5 rows. These are just two random data frames that came up, and I just created them as toy examples to show you guys how you can concatenate them. So in Concat, you also need to specify the axis on which you want to be concatenating. So if the axis is 0, you're concatenating rows. If the axis is 1, you're concatenating columns, right? So this is an argument that you want to give to the concat function because it actually makes a difference, as you can imagine. So here I just give it the list of data frames I want to be concatenating and the axis on which I want to be concatenating, which in this case is the rows. So it just took the two data frames and stuck them together, one on top and the other one on the bottom. So I can do exactly the same thing, but using the other axes. So sticking them together side by side, right? So this is the same exact command, but here the axis is 1, which corresponds to columns, and here the axis is 0, which corresponds to rows. And I can do this for many data frames, as many as I want. So here I just define the list of 4 data frames and I squash them together on the columns axis. So yeah, this is just for combining data frames. Of course, as I said, this can get a lot messier depending on maybe you have tens of data frames and you want them to have common elements. We won't go into that level of detail here, but as I said, Pandas provides some documentation. It has some user guides, and it takes time to understand this stuff. So only by running many examples, you will actually get to know what's going on. This is just an introduction. And of course, okay, this is just something really extra. You can directly plot things from the data frames, which is useful. Although Python provides some really nice libraries for plotting. The thing is that, for example, if you're using Matplotlib, okay, here I'm using Matplotlib to plot, let's say, the age versus the fair. This doesn't actually make any intuitive sense. I just show you how to plot 2 columns against each other. In the next notebook, we're going to see how this actually works. But if you want to do this using Matplotlib, you need to plot the title, then define the scatter plot, and on which columns you want to be. So this is the x axis of the scatter plot. This is the y, and then you also need to label the columns. The axis of the plot. Of course, this is not that bad. I'm just showing you that Pandas can do this in 1 line, and it's exactly the same. So you just do data frame.plot.scatter, and then you define the columns of the data frame. So I want the x axis of the plot to be the age column, and the y-axis of the plot to be the fair column, and just plot me a scatter plot. It's simple as that, and you can get some really nice plots, labeled plots with scales on the axis, and it's really straightforward. Here we did it with 1 line, here we did it with a bit more lines, but this is entirely up to you how you're going to be using Python's plotting libraries, but it provides some capabilities for doing. So for example, here I just did the value counts of the survived column, which I showed you above. So here I just create essentially the value counts of that column. I normalize it, so instead of just the integer count of each value, I now turn it into a percentage, and I can plot a bar chart just using this single line. Okay, so this is really simple. Again, 1 line, and you can also do pie charts and box plots, but we'll see all of this stuff in the next notebook. This is just to show you that we can easily do this. So okay, this completes the first notebook. I know that some of you guys may have done these things before, but Pandas is extremely useful. We're going to see why in the next notebook, when we're going to actually use some machine learning on top of some Pandas data frames to gain some insights, and not just talk about boring functions and stuff. If you have any questions, please fire away. Otherwise, we can go to a break. And okay, actually,
Good morning. I would like to know if, for these examples, the data is small and fits into computer's memory. Can you mount a database in Pandas so you can deal with bigger data set?
Okay, so there's this other library which is called if you if you want to be working with SQL, for example, there's a library which can map SQL queries to essential. You can write SQL queries in Pandas, but of course you can also read SQL data in Pandas. But okay, for the I've personally used huge data sets for my machine learning projects in Pandas, and that was fine. So like millions of entries, and it worked fine. Of course, it depends on the capabilities of your machine, but most of these projects are run on either the supercomputers or the cloud, essentially. So most of the times we actually use this kind of notebooks for machine learning projects because of the issues you just described. So memory issues and also processing power, because later on it's not only the sheer size of the data, you need to also start building machine learning models, which in their own, they're pretty intense. So here you can easily, let's say, mount this notebook to another source online, so on a cloud-based storage, and then you can also use Google's resources to run the machine learning models. So now we're connected to a Google runtime. So Google gives us some GPUs we can use. You can see here we can change the runtime type to GPU or tensor processing units, but this here is of course temporary because we're not paying for it. But in some cases you can just get a professional account where you have much more runtime and much more memory availability. But of course, again, this is Google's product, so I'm not sure if it plays nice with other online storages. But you also have other similar resources provided by other, so you have DeepNode and stuff like that. Yes. Mm-hmm. So
this import warning, what's that about?
Sorry?
You had at some point at the end import warning and something about.
Yeah. Sorry, I'm just. I had a question here from the audience, and maybe just if you have a microphone. Sorry.
My question is about merge and concat. If the dataset that needs to be merged need to be the same length.
So okay, so for merge, you need to have a common column, okay? And even if the dataset is shorter in length on that common column, it's gonna merge the datasets, but it's gonna have empty values for the corresponding part. It's gonna just fill the whole thing with NAs, okay? Now for concatenating, if you saw, you can have different sizes, so you can just stick them together, and again, you'll have NAs essentially. But yeah, this is something you need to think about before. Sorry, Panayota, was that you asking the question online?
Yes, about the warning.
So the import warning here.
Mm-hmm.
So this was just about some visualizations. Sometimes some libraries don't play nice together. So if I run this without that warning, I just get a warning here at the pie chart, but it's nothing extreme. It's just one of those Python warnings whenever they update the library.
Okay, thanks.
Okay. So I just wanted to say that we're going to have another slot together, which is for 1 hour. And then the next slot, which is about text processing using TensorFlow, is going to be fully online, as Christos cannot make it today. So he's going to give the presentation online. So after 1 o'clock for the people here, we can just move the whole thing to a remote setting. So yeah, that's for the people here. Now we can have a half an hour break. Let's meet back here at 12. We're going to have another hour on some data science, some more involved stuff with machine learning and pandas, and then we can just call it a day. For the people here, I think we'll have some lunch if you want, and then we don't want to keep. Yeah, remote. Okay. Okay, thanks a lot. See you in half an hour. So let's do 12, okay? 12 o'clock. No.